All right, good morning. Today we're gonna talk about quadratic functions, okay? Now, y'all know my writing's not the best, so kind of bear with me here when I'm trying to write this. Um, First, we're gonna start about how to identify a quadratic function, okay? So the main two things we're gonna look at are equations and graphs, okay? So to identify an equation, if it's a quadratic, we're gonna look for the largest exponent, okay? So the largest exponent is going to be the second power, okay? Usually it's going to be, well, in our case, it's always going to be x squared, okay? But the largest exponent, if the largest exponent in a function is a 2, it's squared, then it's a quadratic, okay? And we'll look at examples below. If we're looking at a graph, it looks like a U, okay? So it looks like a U shape most of the time, okay? But mainly it has a gentle curve and it's smooth and continuous. Okay? It's smooth and continuous. So it makes kind of like a U shape. But let me show you some examples so you don't kind of get confused. So it can look like this, right? It can look like a plain U, or it can be kind of an upside down U, like that, or it might be kind of stretched out like that. There's a lot of different examples of quadratics that we're gonna look like, but this is just the first couple examples, okay? So if I'm looking at an equation and the largest exponent is a squared power, it's a 2, right? Then it's a quadratic. If I'm looking at a graph and it makes a U shape, so if it has a gentle curve, right, it's smooth and continuous, that's a quadratic, okay? So let's look at some examples. So for number 1, I have y plus 5 equals 2x squared, okay? So if we want to know if it's a quadratic or not, we look for the largest exponent, okay? So if I'm looking at the largest exponent here, I would see that the largest is this 2, right? That is the biggest exponent. These don't have exponents, okay? Even though it looks kind of weird, like the x squared's over here, we're just looking for the biggest exponent. So for this answer, we would say yes. Because the largest exponent is 2, okay? Does that kind of, hope that kind of makes sense? Well, let me try to get that in camera. There we go, okay? Now if we go to number 2, right? 2x plus 3y equals 4. Again, it's an equation, right? So what we need to do is we need to look for the largest exponent, okay? So if I look here, right, I have 2x plus 3y equals 4. I don't actually see any exponents, okay? But remember, if there's like variables by itself, there's an exponent of 1, okay? But are any of those the exponent of 2? If they're not, then we can say no. It is not a quadratic. So you can just say not quadratic because largest exponent, I'm just going to exp, is not 2, okay? So this number 1, this equation is a quadratic function. This one is not a quadratic function. So all you have to do with equations is look for the highest exponent, okay? That's it. Now number 3 and 4, okay? Let me try to get this on here. There we go. So number 3 and 4, we're looking at 2 graphs, okay? So number 3 is on this left side. I can't get it all in the camera. That's okay. Okay, so if I'm looking at number 3, remember my criteria, it needs to look like a U shape and it needs to be a gentle curve and smooth and continuous, okay? Looking at number 3, does that look like a U? Does it have a gentle curve? Is it smooth and continuous, okay? Number 3 is not a quadratic function, so we would say no, okay? Because it is not curved, okay? Do y'all see that? It makes kind of like a real sharp turn there. It's a real sharp turn. It doesn't curve gently, okay? It just goes up and then boom, straight down. So this is no, it is not a quadratic function because it is not curved, okay? Now if we go to number 4, okay? So same criteria. Does it look like a U? Is it gently curved? And is it smooth and continuous? So if I'm looking at number 4, right? It's a U, it's just upside down, okay? Does it have a gentle curve? Yes, it goes up and then curves back down. Is it smooth and continuous? So yeah, you can follow with your pen all the way up and then all the way back down, okay? So this one, we're gonna say yes. Number 4 is a quadratic function because it meets all criteria. So we can just say meets all criteria, okay? So kind of sum up that. So for equations, we look at the largest exponent. So my largest exponent has to be a 2. If it's a 2, it's a quadratic. You're done, okay? If it's not a 2, then it's not a quadratic. If we go to graphs, okay, it needs to fit this criteria. So if it's gently curved and continuous, like number 4, it's a quadratic. If it's not a quadratic. That's it, okay? So that's kind of identifying a quadratic. Now we're gonna shift to, next page, characteristics of quadratics, okay? And these pages, if you didn't get it, that's fine. I'm gonna take pictures of them and post them on Google Classroom once I finish this, okay? Or I guess I'll post it at the same time I post the video. Now we're talking about characteristics of quadratics, okay? So what we call this kind of U shape is a parabola. It's called, I don't know why it's called a parabola, but it's called a parabola, okay? And there's different parts of it that we have to know. So I kind of have one drawn here. Again, it's not perfect, but bear with me. I have the x-axis and the y-axis labeled, okay? So the first kind of characteristic we're going to look at is going to be this one right here. So I'm going to draw a dashed line right down the center of the graph, okay? Right down the center. So what this is called, what this imaginary line is called, I'm going to write it down here. Yeah, you can see that. Is axis of symmetry. Okay? That is the axis of symmetry. And we're gonna define what each of those mean later, but just kind of know the axis of symmetry. It's an imaginary line that divides the parabola in half. Okay. The next characteristic we're gonna look at is this one. So right here, we've actually talked about these type of things before, but we're actually going to use them now. So if y'all saw those 2 dots that I just did, let me try to highlight that. I have a highlighter. So those 2 dots I just did, those are, hopefully y'all remember this, those are called x-intercepts or zeros, okay? Well, there's actually a lot of names for them. So these are x-intercepts. Y'all remember, we found those before. X-intercepts. Zeros, which is the way you're going to see most often in this, I guess, section. So zeros, x-intercepts, roots, and solutions. Okay? All 4 of those words mean the exact same thing. It's talking about your 2 points on the x-axis. Okay? Sometimes you might have 2 points. Sometimes you might have 1 point. Sometimes you might have 0. Okay? We're going to see examples of that later. But just know that wherever your parabola crosses the x-axis, okay, it's any of these things. So it's an x-intercept. You have 2 zeros, 2 roots, 2 solutions. Okay? These 4 words mean the same thing. Okay? The next thing, or I guess the last kind of part that we're really going to talk about is this one down here. Okay? It's kind of like the peak of the parabola. It's like the end point. And we're going to call that, draw it over here. I think y'all have seen this word before, the vertex. Okay? The vertex, in this case, it's the lowest point in the graph. But imagine on the previous page, like we had the upside down U, sometimes the vertex might be on the top, okay? And we're gonna see examples of all this stuff, okay? But these are the 3 main parts of a parabola that we're looking at today. Going down, so sliding down, we're gonna kind of start to define what each of these mean. So we're gonna start with 0. No, actually, we're gonna start with axis of symmetry. So axis of symmetry. Axis of symmetry. Can y'all see that? Yeah, you can see that. Okay, so axis of symmetry. That is a line that divides a parabola into two halves, okay? It divides it into two halves. So again, it's right down the middle. So this is the axis of symmetry. Because see, this side, it's equal to this side, okay? It's kind of like a mirror, I guess. The next word that we're going to define are going to be like this whole big group of words, okay? So I'm going to write them. I'm going to try to write them all. So I'm going to put zeros, x-intercepts, roots, and solutions. Okay? So these are the answers to a quadratic problem. Okay? These are the answers to a quadratic problem. And like I said earlier, they're where the parabola crosses the x-axis. So where the parabola crosses the x-axis, okay? And again, we're going to learn how to write those answers down when we get to examples. The third one is the vertex. Vertex, can you see that? Yes. Okay, so the vertex is the highest or lowest point on the parabola. Okay. So again, like for this example up here, the vertex was the lowest point. Okay. But if we had like a parabola that was upside down, U, we would have a highest point. So this one is lowest, and then we'll see examples where we have both. Okay. And then the last thing I want to write down is going to be the minimum or maximum. Okay, so if we have a minimum, maximum. Okay, so if we have a minimum, that means the graph opens up. Okay, the graph opens up. So if we look at this one, for example, we would have a minimum because the graph opens up, right? The endpoints go up. So there's a big space right in the middle that goes up, okay? And we'll see an example of a maximum, but where the graph will open, if you can kind of guess it, the graph opens down, okay? The graph opens down. That kind of makes sense, okay? And again, if you can't write this down, that's fine. I'll take a picture of this after when I post the videos tomorrow. Third page, okay? So hope y'all okay with that. We're gonna move to some examples of quadratic functions and where we have to identify these parts, okay? So I already drawn these up. Again, sorry, my drawings aren't perfect, but they're okay. So number one, okay, we need to identify all four of these things. So we need to find what the vertex is, the axis of symmetry, the min or max, and the zeros, if we have any, okay? So the vertex, remember the vertex is either the highest or the lowest point in the graph, okay? So just looking at this quadratic, right, you can kind of tell it doesn't really have a highest point because see it has these arrows that go up and up and up and up and up, right? But it opens up, so that means there's a lowest point, okay? So the vertex is this point down here, okay? So we can say, draw a little arrow, that's the vertex, okay? So how we would write that answer is we would write it as an ordered pair, okay? So the vertex, the ordered pair is going to be 1, right? That's my x value, 1, and then down 1, 2, 3, 4. So 1, comma, -4. That would be my vertex. That's it. That's all you have to do. You just have to identify if it's the highest or lowest point, and then write that point down. That's it, okay? The next thing is the axis of symmetry, okay? So again, remember that axis of symmetry was that imaginary line that divided the parabola, okay? So if I draw a line, it's at the vertex. We draw that invisible line, okay? Now, if we kind of remember from Hooyvuk's, right? If I have a vertical line, that equation is going to start with x, okay? So it's going to be x equals, and then the x value that the line goes through, okay? So if I look at this imaginary vertical line, I drew it straight through 1, okay? So the axis of symmetry is going to be x equals 1. Oh, sorry, there we go, okay? So if you kind of see that if you look at my vertex, right? See how I have a 1 in the x value, okay? And my axis of symmetry is x equals 1. This is always going to be true. This relationship is always going to be true, okay? So if you can find your vertex, you can find the axis of symmetry really easy, okay? It's just the x value, so x equals 1. That's it, okay? Now we have to say whether we have a minimum value or a maximum value, okay? So again, if we look at the vertex, was the vertex really, really high on the graph? Was it the highest point or was it the lowest point for number 1, right? So for number 1, it was the lowest point. So we can say this parabola has a minimum. It has a minimum value. Because remember, the vertex is the minimum value here, okay? Hope that kind of makes sense. Okay, now we go to the zeros, okay? So remember, the zeros are where my parabola crosses the x-axis. So if y'all look, my parabola crosses the x-axis 2 times. It crosses right here and right there, okay? So what I need to do is I need to write both of those values down. I'm gonna write both those points down. So right here, if I go over to where it crosses, so this is 1, 0. This is my second 0. So this one, it's 1, 2, 0. So 2, 0. That's my first 0, okay? The second one, I'm gonna write that right here. So 2, 0. The next one is over here. So that point is -1, 0, okay? And that's it. So that's 1, 0, that's 2 zeros, okay? So sometimes you might see them written as this, but sometimes you might just see them written as like 2 and then -1, okay? You might see them kind of written as that, but just know that each of these are your answers, okay? You have 2 zeros here, so you need to have 2 answers, 2 solutions, okay? Remember that. Okay, first example is done. That's it. Let's go to number 2. All right, number 2. Okay, this one looks kind of different, right? It's flipped down, and it just looks a little different, and we'll see why. So again, we start with the vertex, okay? So the vertex is the highest or the lowest point. So here, my vertex is the, hopefully y'all will know it's highest point, right? It's right here. This is my vertex, okay? So again, we just write down that point. So this point, we start at 0, 0, right? We go left 2, so -2, 0. That's it. That's my vertex, okay? Now we go to axis of symmetry, okay? So remember, it's that imaginary line that divides my parabola, okay? So if you can remember the trick from this first example, remember the axis of symmetry, you write x equals first. So we're gonna write x equals, and then it's whatever the x value of the vertex is, okay? So the x value of my vertex here was 1, so it was x equals 1. Here, the x value of my vertex is -2, so it's x equals -2, okay? And if you want to check, you can check that the x value that goes through the middle of the graph is -2, right? Because 1 to the left, 2 to the left, -2. Okay, so it's my axis of symmetry. That's it. Now for min and max, okay, what that means is, do we have a minimum value or a maximum value, okay? So just by looking at it, since my vertex is the highest point, that means I have a maximum value. So I'm gonna go write max here, okay? Because this vertex is the highest point. You see the difference? This one was the minimum. It was the lowest point, so we write minimum. This one's the highest point, so we write maximum, okay? Now for zeros, okay? Remember, that's where the graph crosses the x-axis, okay? So in this example for number 1, it crossed it 2 times, okay? But how many times does it cross it here? Only 1 time, right? Only 1 time it touches the x-axis, okay? So I'm only going to have 1 0, okay? So I'm gonna write down that point. So it's right here, so it's -2, 0. So here, my vertex happens to be my 0. It's kind of weird, but it happens. Okay? So you're going to write it like this, or you might just see it written like just -2. Okay? Just the x value. But remember, there's only 1 0 here. Only 1 solution. Okay? So this one had 2 because it crossed the x-axis twice. This one only has 1. Okay? Third one. Last one. We're almost done. This one's super weird, okay? So here, the vertex, remember, it's the highest or lowest point. So here, if we look, my graph opens up, right? The arrows are going up. So again, this is my vertex, the lowest point on the graph, okay? So remember, we just want to write the ordered pair of this point. So it's going to be 1, 2, 3. So we're going to be 3. And then up, 1, 2. So 3, comma, 2 is my vertex. Okay, so remember, see, this is 3, that's 2. Okay. So now we go to axis of symmetry. So again, remember, axis of symmetry divides my graph in half. Okay. And we remember the little trick. So we start with x equals, we look at my vertex, what's the x value? Boom, it's 3. Done. It's that easy. Or you could just count 1, 2, 3. Either way, it's not that bad. Okay. Next, min or max. Okay. So if we look, is my vertex the minimum value or is it a maximum value? Right. So just looking at it, this vertex is the lowest point in the graph. Right. There's nothing below it. So this is a min. The vertex is a minimum value. Okay. Now this last part, this is kind of the tricky part. Okay. So I'm looking for the zeros, right? I'm looking for where my parabola crosses the x-axis, okay? But if I'm looking, right, does my parabola ever cross the x-axis? If I go all the way across, does it ever cross it? No is what you should have said, okay? So no, it does not cross it. So for zeros, you're going to write none. There is no zeros. There are no solutions on this quadratic, okay? It's kind of tricky, but if it never crosses the x-axis, I have no solutions, okay? That's it, okay? And that's all we're going to do for today. And then tomorrow, I'm going to have another video, or on Tuesday, I'm going to show another video where we kind of review this stuff. But this is all your Google form assignment is, okay? It's just identifying these attributes, and then it's saying whether, like, it's a quadratic or not. Okay, that's it. That's all the Google form is. Okay, so again, if you have any questions, you can just email me or contact me through Google Classroom. But yeah, just kind of bear with me on this. Make sure y'all are trying on this, and y'all have a good day.